Good evening, kids. Welcome back to the second part of Introduction to Coordinate Systems. In this video lecture, we will discuss about computing the dot product of given vectors. In the last class, we have discussed about the three-dimensional Cartesian coordinate system. We have also seen how to compute magnitude of a given vector and also how to determine the unit vector of a given vector. And we have also seen computing the distance between any two points in the space. In today's lecture, we will be discussing about dot product. I hope that by the completion of this lecture, you will be able to determine the dot product of two given vectors. I will start with the basic convention of dot products. Dot products is also called as a scalar products because on performing dot product on two vectors, we will get a scalar quantity. It is nothing but the product of magnitudes of vectors cosine of smaller angle between the vectors, which means that let us suppose if there are two vectors a bar and b bar, it is the product of magnitudes of the two vectors. Let us suppose this is the product of these are the magnitudes of two vectors. This is the product of these two magnitudes and cos of angle between these two vectors. I'll show you the formula now. If you carefully see, if let A and B be the two vectors, then theta AB will be the angle between them. Now, dot product is defined as AB is equal to AB cos theta AB. Now, in rectangular coordinate system, basically, how to determine the dot product? Let us suppose there are two vectors which have been given by, this is one vector, this is another vector. So, dot product of these two vectors, A and B, will be given by multiplication of these things. Ax bx by plus az into bz. So, because these vectors basically is 0. So that's why cos of 0 is 1 because dot product will use product of cosine of angle between these two vectors. So that's why like vectors the angle between them is 0, cos of 0. Whereas or if you take y dot z or if you take z dot x, all these terms they result in 0 because the angle between these two vectors is 90. Cos 90 is basically 0. Okay, so that's why dot product is given by multiplication of like quantities ax bx, ay by, and az bz. So this is dot product. Now we'll do some small problems on this one. And remember that dot product of two vectors is always a scalar quantity. So coming to the small problem. Now let's have a look at a few example problems of how to compute dot product. We'll take two vectors. One is a vector with coordinates of 2, 3 and minus 4. And the other one is a b vector with coordinates minus 4, 2, minus 3. Now the dot product of these two vectors will be as we have discussed in the formula. 2 into minus 4 plus 3 into plus minus 4 into minus 3. See, this is what I have written. 2 into minus 4 plus 3 into 2 plus minus 4 into minus 3. So it is minus 8 plus 6 plus. Now, moving on to one more problem now. Now let us suppose I do have two vectors with coordinates 3, 2, 4 and minus 2, 6, minus 3. The dot product of these two is 3 into minus 2 plus 2 into 6 plus 4 into minus 3. So this is minus 6, this is 12, this is minus 12. So the summation of all these things, they will get cancelled out and you will. So this is what is dot product. And finally, angle between two vectors. This is what I wanted to show you. As already I have said that dot product is nothing two vectors. The dot product is nothing but into cos of theta AB, right? Theta AB is equal to AB dot product, which is the dot product of two vectors, by magnitude of A into magnitude of B. Now, let us determine the angle between the two vectors now. Now let us suppose A vector is given by, as you have already seen, this is A vector and this is B vector. Now we are determining the angle between the vectors A and B. Now A vector, as you know, it can be written as 2, 3, minus 4. B vector is minus 4, 2 and minus 3. Now first of all, let us compute what is the dot product of these two vectors. Now it is 2 into minus 4 plus 3 into 2 plus minus 4 into minus 3. So this is what, and the value is 10. And also magnitude of this one, square root of 2 square plus 3 is minus 4 whole square. So this is minus 4 whole square. It is root 29. For here on, it is also minus 4 whole square plus 2 square plus minus 3 whole square. Now it is also root 29. So cos theta AB, which is, as we have seen in the last formula, it is a dot product of these two vectors. Its value is 10 by magnitude of A into magnitude of B. So 10 by square root of 29 into square root of 29, it is 10 by 29. Okay. So I hope now you will be able to solve this particular problem. Try this at home and come back to the next class. So conclusion is, dot product is given by A dot B, which is equal to magnitude of A into magnitude of B, and we can use the same formula to determine the angle between the vectors. Cos theta AB is equal to AB by magnitude of A into magnitude of B. See, here also these are vectors. Okay, so now what we have come across so far, we are now able to compute the dot product of two vectors, and also we are able to compute the angle between two vectors, right? So thank you. In the next class we will see about the vector product, or what we call it as a cross product of two vectors. Thank you.